Okay, in this video we're going to go over the notes for 7.1. So the first thing we're going to look at is figuring out what is a random variable. So here are our definitions. So a chance experiment, the example is going to be Nikki's foul shooting. Okay, that's the example of a chance experiment. And by definition, it's a situation with more than one outcome. Okay, so she can either make the shot or miss the shot. So she has two outcomes. So a random variable, an example would be Nikki's score. And the definition is that it's a quantitative, so it's a number, quantitative variable whose value is determined by the outcome of the experiment. Okay, so if the experiment is Nikki taking foul shots, the outcome is going to be the score. So if she makes it, she gets a point. If she doesn't make it, she doesn't get a point. Okay, so our first example is Nikki's basketball free throw problem. So Nikki is a 60% free throw shooter. So that means 0.6 is the probability of her hitting a free throw shot. So Nikki's in a 1-in-1 situation, so that means if she makes the first shot, she's allowed to take a second shot. If she doesn't make the first shot, there is no other shot. So model this with a tree diagram. So we need a tree diagram to determine the probability of Nikki getting 0, 1, or 2 points. Okay, so this is the theoretical probability. So here comes her first shot, and she has a 60% chance of making it and a 40% chance of not making it. If she makes it, then she gets to have a second shot, and she has a 60% chance of making that and a 40% chance of not making it. So notice that her 0.4 side is a dead end because if she doesn't make the first shot, she doesn't get another shot. So what are our outcomes? So let's figure this out. So the outcomes, she can get 0 points, and that would be if she comes down this line and misses the first one. So that's a 0 point. And what's the probability of that? That's going to be 0.4. Okay, so then she also can make just 1 point. So if she makes 1 point, how does she do that? So let me get another color. So to make 1 point, she's going to come down here, make the first shot, and then miss the second shot. So notice that what I'm going to do is multiply the probabilities. So that's going to be 0.24. Then her other option is she can make all of the shots, and then if she does that, she's going to get 2 points. And how does that work? She makes the first shot, and she makes the second shot. So that probability is going to be 0.6 times 0.6, which is 0.36. So if we add these numbers up, what we find is that this sums to 1. So we know we have taken care of all the probabilities. Okay, a couple of quick things. This is theoretical. This is what you get in theory. If you want to figure out an experiment, so let me change colors. If you want to figure out an experiment, what you would do is use your calculator, and you can do the random integer. And so what you would go to is math, and then go to 5. And then you would select your random integer. So once you're on math, and go to probability and then go to 5, and it's going to ask you for a lower number, an upper number, and your N. And you would fill that in, and then it would generate numbers for you. So we'll do this in class, but that's where it is. So I'm going to say, go to math, go to probability, and then go to 5. Okay, so we'll do that in class, but that's where it is on your calculator. All right, so let's go on to the next page. Okay, so what the author has done in our textbook on page 86, he has modeled the Nikki 60% free throw shooter for a one-on-one situation as a 10 by 10 grid, and that means he's modeling 100 trips to the foul line. So look what's happening here. The first shot hits, that happens. So that combined with the second shot hitting will give 2 points. Okay, so I'm just going to fill this in with 2 points. Just so you can visually see what the score is. If both of these things happen, she's going to get 2 points. And what is this area right here? Well, let's figure it out. It is 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6. And what is 0.6 by 0.6? That is 0.36. So the 0.36 is right in here. So let me just change this to like a bright color. Here's red. So this is 0.36. Okay, what if the first shot hits and the second shot misses? What happens then is her score will be just 1, right? So remember, she's going 100 times to the foul shot, given this example. That's why I have a 10 by 10 grid. So what is the percentage here? Well, it is 0.4 times 0.6. So it shouldn't come as a surprise that that is 0.24. Okay, what happens the rest of the time? Well, the rest of the time, if the first shot misses, she's actually done. So all this is going to be 0. So even though she's not taking a second shot, I'm just going to fill this in as well. And you can see that with all these zeros, this ends up being 4 times 10. So what is that in terms of probability? That is going to be, so we'll do a different color. That is going to be 0.40. All right, so this lines up with our tree table and our outcomes table. Okay, so another thing they talk about is what would be her expected points if she goes to the foul line 100 times. So to get expected points, that is going to be a weighted average. So what you're going to do is you're going to take each of the values. So take the value times the probability, or times the number of times number of points she would score, given that she's going to the foul shot line 100 times. So you have 2 times 36, because you get 2 points, and you get that 36 over 100 times, right? Plus 1 point, you would get 24 times, because the probability is 0.24, and then times 100 makes that 24. And then 0 points, you're going to get that 40 times. Okay, so add those up, and you should be getting, this is, 72 plus 24. So that means that if she goes to the foul line 100 times, her expected points would be 96. So that's pretty good. Okay, and that's in the 1-on-1 situation. All right, so that's one scenario. Let's go on to the next page for another scenario. Okay, so here they say Nikki's a 60% free throw shooter. Okay, so that's still the same average that she's having. But now this time, she is in a 2-shot free throw. So it's not 1 and 1, it's 2. So she must have been fouled while taking a shot. So model this with a tree diagram to determine the probability of Nikki getting 0, 1, or 2 points. Okay, so this time, unlike the 1 and 1, she doesn't have a dead end for the lower tree, or the lower branch. So this is 0.6, this is 0.4, this is her second shot, this is 0.6, this is 0.4. So now she has 1, 2, 3, 4 different options here. So let's figure out what it is that she's getting. Okay, if she's going to get 2 points, if she's going to be able to get 2 points, where is she going? She's going to go down the success line and then again down the success line. So 2 points is going to be the gray, and that's going to be a percentage or probability of 0.6 times 0.6, which is 0.36. Okay, what if she only earns 1 point? How many ways can she do that? So what if she made the first shot but missed the second shot? That's one way. So that's going to be 0.6 times 0.4. Or she could have missed the first shot and made the second shot. And that probability is 0.4 times 0.6. So they're both 0.24, and you would add them up. And so they sum to 0.48. Remember, you multiply going down rows, and then you add vertically. Okay, so there's another option. She could get 0 points. So how would she get 0 points? Well, she would get 0 points if she missed the first shot and then missed the second shot. And the probability of her doing that is 0.4 times 0.4, which is 0.16. And again, if you sum them, you will get a 1. Okay, so they want us to model this also with a 10 by 10 grid. So a 10 by 10 grid is the assumption that you are going to the foul line 100 times. So let's do that on the next page. All right, here's our 10 by 10 grid. So if the first shot hits and the second shot hits, she's going to be getting 2 points. Okay, and remember what the probability of that happening is. So it's 0.6 times 0.6. But in this case, it's 6 by 6. So that is going to happen 36% of the time. Okay, so 36% of this grid is 2 points. Okay, what if either the first shot misses and the second shot hits, or the first shot hits and the second shot misses? That's going to give you just 1 point. So I'm filling in all of these with 1 point. Okay, and what's the percentage of that happening? Well, down below, it's going to be 0.4 times 0.6, which is 0.24, or 24%. So I'll make this a darker color. So this will be 24%, and this will be 24%. So she has 48% of the time she's going to end up earning just 1 point. And then the last scenario is if both shots miss. So if both shots miss, she will end up with 0 points. So how will that happen? Well, that's going to be 0.4 times 0.4. So that's going to happen 16% of the time. All right, so given this grid, we can now figure out our points expected. So these are the expected points. Expected points given 100 trips to the foul line. All right, so let's figure this out. So we have 2 points she can get, and she'll get them 36 times. Plus, she could get 1 point, and that would happen 48 times. Plus, she can get 0 points, and that would happen just 16 times. So this is going to be 72 plus 48 plus 0, which is 120 points, would be her expected points given 100 trips to the foul line. So notice, when she is in a 2-shot situation, her expected points are 120. And let's go back. When she was in a 1-and-1 situation, her expected points were 96. Okay, so we have 2 good things going on here. Okay, let's continue. So I have that grid already, so I really don't need this page. So we're going to skip that. Well, hold on. Let me go back and see what else we have here. Oh, there we go. Okay, so we have a second girl. Her name is also, unfortunately, Nikki. But this is Nikki with 2 Ks and an I. Now, she is a little bit of a better free throw shooter. She has an 80% success. So what is her situation like in a 2-shot deal? Okay, so notice they didn't do a 1-and-1, but let's compare her 2-shot to the other Nikki's 2-shot. And the other Nikki was a 60% free throw shooter. Okay, so first off, we need a tree diagram. So let's set that up. So here's the first 2 branches. She makes the shot. She does not make the first shot. Then let's go for the second shot. She can make it. She can miss it. Same thing down here. She can make it, she can miss it. So there's no dead end because it's not a 1-and-1 situation. So what are this Nikki's probabilities? So she can get 2 points if she makes both shots, right? So I'll do it the same way I was doing the other. So if she makes both shots, that means you're going down these branches. So to get 2 points, it's going to be 0.8 times 0.8, which is 0.64, or 64% of the time. Okay, so then her next option is she can make 1 point. So she makes the first one, misses the second one. Misses the first one, makes the second one. Both of those scenarios will give her 1 point. So that's a 1 point, and both times it's either going to be 0.8 times 0.2 or 0.2 times 0.8. Those are both 0.16s, and you add those vertically, so that's going to be 0.32. Okay, so then you have the third scenario. The third scenario is if she's having a bad day, and she misses the first one, and then she also misses the second one. So that will give her 0 points. So that's 0.2 times 0.2, which is 0.04. All right, so if you add those up, they should sum to 1 because you have taken account of every possibility. Okay, so we're going to model this with a 10 by 10 grid. I have more room on the next page, so let's do it there. So here's our 10 by 10. So I have to set this up. So let's say this is second shot hits, second shot misses, and this is, we'll say first hits, first miss. Okay, so what's her probability? It's 0.8, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm going to come here, and then I'm going to go 8 across again. 1, 2, 3, 4, 5, 6, 7, 8. Remember, because she's an 80% foul shooter. And then over here, we are now set. So let's fill in our points. So if the first and second shot hits, she's going to get 2 points for that. So fill in all of these as 2s. So here, I'll let you do it, and I'll fill it in and turn this back on in just a second. Okay, so I have all my 2's filled in, because remember, this grid's going to help me figure out my expected points. So with all the grids filled in, this situation is going to happen 64 times. Okay, so then you have other options. What if either the first one hits and the second one misses, or the first one misses and the second one hits? Okay, what's going to happen there? So I'm going to change color and fill in all the 1s. Okay, and remember, each of these is going to happen 16% of the time. So this is 16 and this is 16. And then the last scenario is if the first one misses and the second one misses. So that's going to result in 0s. And that's going to happen 4 times out of 100. So let me get my red back. Okay, so this is going to be 4 times out of 100. Okay, let's use this grid to get our expected points. Now this is expected given that she goes to the foul line 100 times. So it's going to be 2 points she will get 64 times, plus 1 point she's going to get 16 plus 16, so that's 32 times. And then she's going to get 0 points 4 times. So 2 times 64 is 128. If I would add up all those 2's, I would have gotten 128. Plus, if I added up all the 1's, I would get 32 plus 0. So her expected points are going to be 160 points. Okay, so and that's for 100 trips to the foul line. So how does that compare with the other Nickies? Let's go back for a second. Okay, Nikki's were 120 because remember she was a 60% foul shooter, and this Nikki's is going to be 160 because she is an 80% foul shooter. Okay, so that's one scenario, and we've done tree diagrams as well as this 10 by 10 grid. Okay, so then the textbook goes through another situation. It says that they want you to evaluate this game. This is how the game works. Players take turns rolling 2 number cubes, and they add them up. So player A gets 1 point if the sum is 1, 2, 3, or 4. Player B gets 1 point if the sum is 5, 6, 7, or 8. And player C gets 1 point if the sum is 9, 10, 11, or 12. And they want to know, is this game fair? So to analyze fairness, what we're going to do is we're going to figure out, given that we have 2 die, and they each have up to 6 dots on them, right, for every side, we can figure out what the possible outcomes could be. Okay, so if both die show a 1, your possible outcome is 2. If one shows a 2 and the other one shows a 1, it's 3. So I'm going to go ahead and fill this in by just adding my pink across the top with my pink across the bottom. Okay, so you can do this as well. And you can see there's a pattern that's developing. So see how you're scooting over each time? And then this is going to be 7, 8, 9, 10, 11, 12. Okay, so we're assuming that the die themselves are fair, that there's no one side that's weighted. Okay, so given what we have, this chart right here gives us the summation of all the dice, okay, all the different rolls that we could possibly do. Okay, so then they're going to have us figure out a probability chart based on this. Okay, so I'm going to do some things here so you can see what the pattern is. So let me take another color. Maybe we'll take a pink. Okay, so look what happens. Here we have all 3s. Here we have all 4s. So there's 3 4s as a possibility. There are 4 5s. There are 1, 2, 3, 4, 5 6s. 1, 2, 3, 4, 5, 6 7s, and then it goes back down again. 5 8s, 4 9s, 3 10s, 1 11, and 1 12. So there's 1 12 and there's 1 2. So let's figure out this probability chart. We'll do it on the next page. You may need to come back and look at your notes as you're doing this. Make sure your notes are filled in. Okay, here's our chart. So what I see is the sum can never be 0, okay, because I don't have a 0 die. So I'm going to fill this chart in now. So the probability of getting a 1, that happens 0 times. Getting a 2 happens once, and remember getting a 12 happens once. Getting a 3 is going to happen 2 times, and getting an 11 happens 2 times. Getting a 4 happens 3 times. Getting a 10 happens 3 times. Getting a 5 happens 4 times. Getting a 9, 4 times. Getting a 6 is 5 times. Getting a 7 is 6 times. And getting an 8 is also 5 times. So let's figure out what player A would get. So player A, how many times will he get a point? So let's see. He's 1, 2, 3, or 4. So 1, 2, 3, or 4. Add them up. I have 3, 4, 5, 6. 6 times. And how many possibilities do I have? I have 36. It's 6 times 6. So 6 added 36 times. He or she will get a point. What about player B? Player B gets a point if the sum is 5, 6, 7, or 8. So 5, 6, 7, and 8. So add those all up. This is the best deal yet. So that's 10, and another 10 is 20. So that happens 20 added 36 times. He or she's going to get a point. How about player C? Player C gets a point if it's 9, 10, 11, or 12. So that's 9, 10, 11, 12. Add those up. 4, 7, 9, and one more is 10. So 10 out of 36 times. So this is therefore not a fair game. If it was a fair game, everyone would have the same chance, the same probability of getting a point. And that is not the case. So you would say this is not a fair game. Okay? So that brings us to 7-2, so I will do another video for 7-2.